Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we grow weird and wonderful science emulated into your ears. I'm Ian Woolf. On this edition, we leave the Singularity University Australia Summit speakers for a walk among the booths. At the booths, people are creating jobs, dealing with ocean plastic, and how fungi will save us all.
How the bots are going to be looking like? How the Facebook bot, you know, like way better than Facebook. Yeah.
No jobs? Then learn to create your own. Nonto Nkiwane is the head facilitator at Bop Industries. I stopped at her booth at the Singularity University Australia Summit and began by asking, what is Bop Industries?
So Bop Industries is a tech and education startup. We primarily work with primary and high school students, and the core of our work is teaching students how to start businesses while they're still in school, with the focus on using digital technologies, but also being creative and making technology fun.
How do you do that?
So it's a lot of design thinking. So the way we start our workshops out is we have them playing around with some technology that we have here. So at the summit we have all the different tech that we use in the classrooms, and so showing them different things. So it's all like a different kind of technology. Let's play with it. How does it work? Understand it, and then get them to brainstorm different problems. So we do global problems, national problems, community and personal. So really have them thinking about things that are going on in their lives, and then let's find solutions for those things. And in that group of solutions, let's pick one and turn that into a business. But when you turn it into a business, let's focus on using some form of digital technology, because that's the direction that the world is going. So getting them confident in using different kinds of tech and using tech as a tool, because at least I found with older generations now, tech is something that's kind of scary for us, and there's a lot of this disruptive stuff that's happening in industry that we have no contact with at all. And so you find out about things when it's already on the market and it's scary and you don't want to know about it. So making sure that we're catching kids while they're still young. So it's like, robots. We've played around with spheros. I know how to code one of those and I know how it works. So how do I turn that kind of technology into a tool for doing something else? Turn it into a business, help someone's life. So it's a lot of, okay, let's find solutions to problems. Can be anything. Let's turn that into a business. So it's a lot of thinking outside of the box, but also, I can make a few dollars outside of school, which is really nice.
So you're teaching them programming and you're teaching them bits of electronics and science and a little bit of engineering and entrepreneurship.
Yeah. So not so much the coding. So we let them learn how to code in the classroom, and I think the way I explain it is they're learning all this really deep, intense theory in the classroom, and a lot of the time when you're learning things, you're like, how is this relevant to me? So you're learning all Newton's 3 laws of all the wonderful things in the world, and it's like, okay, cool, I don't really care about Newton's laws, and I'm learning how to code, but I might not be interested in that. And we're taking the stuff they're learning in the classroom and making it practical for them. So kids are starting to learn how to code in like grade 1, grade 2, and it's like, okay, you know how to box code, and now let's play around with the sphere and let's make it fun, because when you're in class, a lot of it is you're doing things for assessment and because you need to get things done. And so we try to make the things they're learning fun and make them practical and applicable to different areas in their lives. So even with, say, engineering, we aren't necessarily teaching them any fundamental laws about anything, but we do run a lot of like bridge building challenges where they're using the concepts that they've learned in class to put things like spaghetti and straw together and using marshmallows. So it's just making learning fun, I think. Yeah.
Fun and practical.
Exactly. Yeah.
So where do people find Bop Industries?
So we are on all forms of social media. So I think if you head to our Facebook, for anyone who's looking to see what kind of programs you're interested in having your kids signing up, or maybe for corporates who are interested in maybe doing a little bit more educational outreach, we do a lot of that kind of work. We have an aviation program that we run with Virgin and a future of transport program we run with RACQ. So everywhere on all socials, we're at Bop Industries. And yeah, just for the big kids, the tech that we have here it might seem simple, but there's so many ways that you can apply these basic concepts for everything. So take our augmented reality, for example. People are using that for marketing. Kids are using it to learn stuff in school. It's something that I think in the future we'll be seeing a lot more of, because QR codes are going to become obsolete because you're able to use AR in a way that's more immersive, because you can scan something and spin it around. So yeah, just for anyone who's going to pop by our store and everyone who's going to maybe research these technologies, it doesn't have to be anything that's like super scary. Really simple and more of like that big picture thinking of what these tools can do for you moving forward. So where to find us at Bop Industries everywhere.
So you're teaching the kids to look for problems and then solve them and turn that into a business. So if you found a problem to solve, what's the step to turn that into a business?
Okay, so the first thing you want to look at is defining what the problem is. Why is it a problem? And you found what the solution is. So they come up with all kinds of different things for solutions, and one of the things I teach when I run workshops is what's the most practical way to solve this. If we were to give you $100 now, how would you solve that? But at the same time, given that constraint, if you were in another scenario, have no constraints at all, and you're allowed to use all this technology, how would you do that? And we want to find a place in between those two points in them where it's like, okay, I can use technology, but I want to be able to push this out really quickly. You want to understand a lot of the time kids come up with problems and don't really think about things like their customers. So we do a lot of customer persona stuff. So I'm trying to sell a robot to someone. What does it do? What kind of functionality do I want it to have for the end user? We do a lot of product design. So if I'm actually using your product, if you're designing it from scratch, what kind of little bits do I need to put in to make it really easy to use? We do a lot of marketing stuff as well. So again, going back to what the product is and who your customer is, how am I going to sell it? Teaching them how to take advantage of social media as a tool as opposed to something that you just play around on. But yeah, so we sort of step them through all the little bits of building a business, making sure they're coming back to what the problem was, so keeping them focused. And we have a huge focus on social enterprise as well, so making sure that as you're solving a problem, you're keeping your end user in mind. And so just trying to be like getting them to look at the world and see problems as things that they can solve, and see everything that they're learning, everything's a tool. So you'll learn something new. How can I apply this thing that I've learned to solve a problem? It can be anything really. So that's sort of how we step them through the problem solution. Let's start a business.
Well, Nonto, thank you very much.
Thank you so much for having me, Ian.
That was Nonto Nkiwane from Bop Industries, teaching kids to create their own jobs.
In the laboratories of Your Name Here, there is a modest sign. And here, dedicated scientists face the challenge. Years of heartbreaking failures and setbacks only stiffen their resolve to conquer the problem. And one day, a strange and historic accident.
Uh-oh. Well, you did it again.
Gee, what a mess. Oh, well. Wait a minute. Maybe... Listen.
By gad, do you suppose this freak accident...
Of course. That's it. That's the answer. We've done it. After all these years, we've invented it.
How about that?
Oh, no. That's no kind of a thing to say. This has got to be some sort of a line that'll get quoted, like, well, how about this? What hath God wrought?
Good. Beautiful. Let me get that down.
And with those historic words, the search was over. From the laboratories of Your Name Here had come the key to the secret that had baffled man through the ages. No longer a dream, but a reality was Your Product Here. Now, for the first time, limitless horizons open for the nation. a brighter future unfolded. Thanks to your name here, employment boom. Not only in the vast modern facilities of your name here, but in factories everywhere, geared to supply this vital new industry that is reshaping our economy and transforming the lives of millions.
You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Plastic pollution is a problem. Alexandra Ridout leads partnerships for the Seabin Project. I visited her booth at the Singularity University Australia Summit and began by asking her, what is the Seabin Project?
So the Seabin Project is a two-tiered solution. We're trying to clean up, which is trying to resolve the issues of trash and plastics and in the ocean and things that end up there in our waterways that really do not belong there. We run two main programs to achieve this or help this, and one of them is our reactive solution, and that's our physical clean technology. It's called a Seabin, literally a trash can, and it's a very good-looking trash can, if I may say so myself, and we put it into marinas, waterways, anywhere that has a fixed floating dock. So it sticks to the dock, it collects. It's got a pump motion in the bottom. It acts like a filter, and it sucks water through, and the water pulls plastics, microfibers, any other trash, things as small as a match top, the head of a matchstick can get caught in there. It also collects oil, gases, things, that sticky film, that gack that's sitting in marina, that sits around boats and that sort of stuff. And then the other half of the Seabin Project is our education program, and we believe this is our preventative. So we believe that that the Seabin is not a full solution to everything. It helps and it's great, but education is going to be the thing that drives solutions. Education won't work overnight, but it will work. And so as part of that, we run a heap of STEM workshops, and we do these in schools. Kids love it, and they engage in their schools ranging from 8-year-olds, 7-year-olds to university kids. Oh, they're not kids anymore, they're adults. And then we do them in corporates, so we go into offices and run a STEM workshop, the same one that we do with the kids. We adapt it for the adults, and funny, it has the same reaction, and it's good, it's effective. And then we do the same things with community events. So we do try and engage communities. We find they're our best advocates, and they care, people in those communities, because they're the ones that are seeing the trash in the waterways that's going to eventually end up in the oceans and in sea life.
And how long has the Seabin Project been going?
We've been around for 5 years, but the actual product, the technology, has been in the water for about 15 months now. We're global. We've got around 730 bins worldwide and across 52 countries. We've just recently moved back to Australia. Well, our founder has, and we're now trying to expand here in our home country a bit more.
Can it pick up microplastics as well?
It sure can. We collect a lot of microplastics, things as small as 2 millimeters. As I said, matchbox heads, so the top of a match, things as small as that. Yeah, and we get a lot of polystyrofoam, things like that. You get some really crazy things in there, and it's interesting to see because we also run a data program, which is another big part of what we do, because it gives us measurable, the more tangible impacts, and also helps us track the statistics of what we are collecting, how much we're collecting, how much water we're filtering. One bin will collect around 4 kilos of rubbish a day, capacity for 20, it collects around 4 kilos. If you do the maths with all the bins, that ends up being a huge amount. So we would do about 1.8 tonnes a day, which is pretty amazing. I know it's small in the grand scheme of things, but it's pretty amazing when you think about it.
It's a huge amount of rubbish for one lot of bins for one organisation per day.
Yeah. Well, we always like to say while you were sleeping, our bins were collecting, working very hard, cleaning the water, getting all this out, getting all sorts of cans, coffee cups, plastic bags.
Are they deployed in Sydney Harbour?
We've got a few down in the sea, down outside the Maritime Museum. We've got some at Jones Bay Wharf. We've got 3 there. There's our first public one is in Rose Bay, which was RMS, got on board with that one. So yeah, we're in Sydney. And Sea Life just recently bought one as well and got on board.
And what organisations you work with?
So one of the things that I'm trying to grow is our partnerships. So I'm looking for more impact partners, companies that want to get on board, help us have a bigger impact and make a bigger difference, because it's hard to do it alone, especially when you're a small company like we are at the moment, a small startup. So we've got a few companies that we work with, but we're really looking to expand that. And, we have a great package which is attractive to the corporates.
Alexandra, thank you very much.
Thank you so much.
That was Alexandra Ridout from the Seabin Project. Find out more at seabinproject.com. Can fungi save us all? Alicia Dudek is a co-founder of Mycoreality. I stopped at her booth at the Singularity University Australia Summit and began by asking her, how can fungi save us all?
It all started with Paul Stamets' TED Talk, The 6 Ways That Fungi Can Save the World, which started with things like medicinal and antiviral properties and bioremediation through mycoremediation. It's progressed now. There's people all over the world doing amazing things, and that was our goal in bringing the Future of Fungi booth to Singularity University. We wanted to build an experience to give the Australian attendees of the summit the experience of some of these solutions to some of the world's biggest problems. One big one is mycobioremediation, so removing heavy metals and petrochemicals from the soil. We have mycocomposite from a company called Ecovative Design in the US, a styrofoam and packaging replacement. Yeah, we've got lots of things. What would you like to know?
Lots of things. Okay, so you've got basically a styrofoam replacement that you can grow.
Yes, definitely. So Ecovative's been at it for 12 years in the US, and it's basically a mold or a form into which they add a substrate, that's what fungi eat, and then the mycelium grows through it, and then you have a very light, dense, solid mass that can be used to ship whatever shaped product you need. And this can then be composted in the garden and is gone much faster than its styrofoam replacement.
So why would people even use styrofoam? This seems enormously better.
Styrofoam's probably highly subsidized by certain companies to be cheap. And this is still a bit expensive, but as with all technologies, we all know that's a function of time, and those prices will change.
Well, particularly if we have more regulation about what happens with the waste.
Oh yeah, the minute you start pricing waste, the entire fungi industry of the world is going to explode exponentially. Every company will be looking at circular economies, closed loop thinking, and fungi in the world, they play a very interesting role in nature, which I believe they'll mimic in economies very soon. So in nature, they are decomposers of matter, recomposers of matter, and they are a structural connective support network. They help the trees talk to each other and share nutrients. And when you listen to a lot of the speakers here at Singularity University Australia, they're talking about the same things. Be a connector, be adaptable. You look at resources differently. So if you want to change 1 billion lives, you need to think like a fungi.
So you talked about the trees talking to each other. So you're referring to the network under the soil, the Internet of Trees.
Yes. So one of the words you'll hear on fungi is mycelium, which is the common way it's talked about is it's the tree to the fruit, which is the apple. So the actual mushroom that we're all eating or using is often the fruit, and the mycelium's the network underground, the tree, if you will, made of thousands, millions of tiny little tubes called hyphae, similar material to insect exoskeletons, chitin, and other things like that. And that's actually the network that uses 7 atmospheres of pressure to take its way through matter, and lots of very interesting ways for matter to be recomposed through them.
And you've got all sorts of things here. You've got something there about fungal intelligence.
Yeah. So my favorite internet article of the last few years is watching the yearly Fungi Olympics. If you haven't heard of it, you will now. Basically, there's a labyrinth. 18 countries competed in the last one, I believe. Australia being a first-timer that year. All these teams of mycologists, they pick a fungi, they release it at the mouth of the maze, and then they time how long it takes it to get to food. Part of this is, fungi seek information, they transmit information, they make decisions, they test options. These are all kinds of ways that you see them moving by sensing their environment. And the Fungi Olympics is a great test of that, and I'd have no doubt it'll heat up in the years to come.
And so you've got other things around here. So what else about fungi are you talking about here?
I think my favorite story is a very homegrown Australian story. So the endeavor is called Soil Sea Quest. Soil, the letter C, Quest, because they are trying to figure out how to industrialize gigaton level carbon sequestration through a collaboration between fungi and mass producing industrial farmers. So the story as it goes, there's a documentary about this called Grassroots. There was a University of Sydney mycology scientist. He had gone around and collected all sorts of wild fungi. One of those is an endophytic carbon fixing fungi. So what that means is endophytic, it's symbiotic with plants. It comes up to the plant roots. It knocks on the door. It says, "Will you let me in? I'll be useful." The plants say, "Sure, come on in." And they form a symbiotic relationship where the fungi extends its ability and also sequesters carbon through this relationship. So as it does that, it actually pulls down long-term sequestration of carbon, which is different than carbon that you would quickly sequester and then quickly releases later. So farmers currently, they already plant seeds that are covered with nitrogen-fixing bacteria. And this startup / research center, so it's both, it's a nonprofit and a startup, this farmer named Guy got together with a whole bunch of folks, and they're trying to create that same mechanism with the fungi. So farmers on an industrial level will buy seeds coated in this fungi. It will then go in the ground and sequester carbon and fix carbon of the soil, which is the major problem farmers want fixed. They've been augmenting soils as much as they can with year after year of harvests from them. So this is like two solutions in one. Sequester carbon from the atmosphere and put it in the soil where the farmers want it. So Soil Sea Quest is trying to put those together.
That's got to be way better than biochar. I mean, if you're just burning things to put in the ground, creating all that extra pollution, when you could be making fertilizer.
Of course, and also it's a delivery system that is fitting into everyone's existing paradigms and marketplace behaviors. So a farmer, a distributor, everyone's going to get it. You're like, oh, this is just like those other seeds that are coated in that other nitrogen fixing thing. This one just fixes carbon.
You've got a competition for a grow box. How difficult is it for people to grow their own?
Can you read instructions and follow them? Which is a two-headed question, as you would know. Most of the grow boxes that people get started in their love of fungi, you open the box, you pop out a cardboard panel, you maybe score a bit of plastic. It's a grow bag inside that's been autoclaved. And then you need to spritz it regularly or put it in a bit of a bag and you spritz the bag around it 5 to 6 times a day. And that should make it go. But it is regularity and, the day can be full of surprises. So the bioreactor, which is based on, it's a relationship to a biodigester. Basically, it's a self-contained vessel. You put in a fungi-based starter slurry. You put in all the waste you want, and it creates a biogas. That biogas can be siphoned off, pressurized, cooking, heating, whatever you need gas for follows. And out the other end comes mushroom compost. So from waste, you get energy as well as yet another thing to augment your soil. I think I'd just like to say that I have met very few people who haven't fallen more deeply in love with fungi after they allow their innate love to bloom. So once you get started, get ready to have a new hobby.
And do you have somewhere online people can visit?
Sure, we have a LinkedIn page and a Facebook page. You can find us under Mycoreality, MYCO Reality.
Well, Alicia, thank you very much.
Thank you very much, Ian.
And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or makeup who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, 2XXFM in Canberra, and my local station, 2RDJ in Burwood, New South Wales. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 950 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/Ian Woolf. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio and leave a comment. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick. Everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.